Hi there, Jay Tedeschi, Senior Technical Marketing Specialist with Autodesk here. Today we're going to take a look at some of the assembly modeling capabilities of Inventor Pro 2016. We'll start here with our Spark printer and drill down into one of the subs. You'll notice that as we do so, we are out automatically of the express mode into the full load of the assembly. We're going to begin by building a little subassembly here. This is the slider plate for the linear drive. We're going to pop in basically just a guide. And we'll place that here, populating this subassembly, and take advantage of some of the joints. This is very similar to the constraint environment. However, the joints which were introduced to Inventor several years ago are significantly more advantageous if you are following up the design with any sort of dynamic simulation where joints are used as opposed to constraints. In the past, if you use constraints, those constraints are automatically converted to joints in dynamic sim. However, this basically eliminates the need for that if you use joints. You'll notice, however, I am still using constraints where it makes sense, and this is one of those areas. So, for example, not only do I want to set this new assembly here flush to the back of the linear slider, but we want to determine some distance of linear travel that this constraint is going to, later on we're going to use this to drive the assembly. So 170 millimeters of motion on this linear slide. Let's roll around to the other side here. And let's begin by placing another component. Now this time we're going to take a look at utilizing some of the AnyCAD capabilities here. Now we're loading up a CAT product. This is a CATIA, small CATIA assembly. You'll note that we are linking it. We're not converting it. We have the ability when we link these from the manufacturer's native files to essentially do selective import. And in this case, there are only 4 parts that make up this little assembly, this linear slider assembly. So we're pulling all 4 in, but we do have the capability of selectively importing only those components that we really need. In this case, it's not that heavy of a subassembly, so we'll just leave it as is. Again, we're going to utilize the joint environment, and we will go ahead and place this rotational joint here, right where the slider attaches to the entire sliding assembly. And we're going to align essentially these 2 back faces. So the back face here of the nylon slider, we'll select through the part, pick that back face, and we'll pick this front face right here. So those are now in alignment. Now let's add another joint. This one's going to be a cylindrical slider, so we'll pick right on that cylindrical edge, and we'll pick the long rod that it slides on as well. And voila! Now the whole point here is that we are determining the motion environment for our assembly. Now we're going to use a pattern array to essentially a rectangular pattern. We're going to essentially copy this in a linear fashion along the side of the linear slider trolley, and we'll then use copy, and we'll just essentially pattern using a rotational pattern. Let's pick these 2 components and let's pattern them around the center axis of the entire tray right there, and we want 2 at 180 degrees. Beautiful. Hopefully you're starting to see how quickly and easily this rather not complex assembly, but not a simplified one either, was put together through a combination of utilizing AnyCAD to take advantage of some components which were created by one of our other divisions, utilizing CATIA as opposed to in the native software that I am using, which is Inventor. Interference checking is used to ensure that there is no interference. And finally, let's go into Content Center and place a couple of fasteners. We can filter out based on DIN. I want to see only the DIN socket head fasteners. We'll select this one right here. You'll note that once I pick, we are able to selectively from the catalog pick only those lengths which can be purchased, as well as auto-populate all of the holes in the array. key takeaway here is that bill of materials is always going to be updated and kept up to date based on these additions to the assembly. Now, based on the values that we entered in when we added that first constraint, that cylindrical constraint, we're able to drive this back and forth and evaluate the motion, showing that the linear sliding assembly in that it goes through in its normal range of motion. And with that, I want to thank you for your time, and I'll look forward to seeing you again.